welcome to another edition of our climate change discussions. We're the climate change brothers. Matt and Frank and Matt, whatever. Dr. K, what do they call you now? Doctor, they salute
Dr.
you and
Catman
all.
or
Catman,
something.
okay,
Yeah.
well, that's good. All right, so anyway, we're a couple engineers. You're agricultural mainly, and I'm electrical, but we do like to talk a lot about issues that are on our times for climate change.
One measure that would help reduce methane emissions from cows is by providing them with feed additives.
And so two of those measures are having better, putting in feed additives into the cattle food.
That's a good idea too.
That actually have been shown to reduce methane emissions from the cows.
Right.
So they can do that. And
Well, what are some examples of some feed additives?
one thing, this University of California professor you're talking about, I think it's the same guy. Okay, so he did experiments on adding red seaweed to cattle mixtures, feed mixtures.
That's good.
And he was shown that gave an improvement. It actually reduced it by almost 80%.
That's great.
Methane emissions. Yeah. I don't know how much the cow like it, but I mean, I think that if you mix it in, it's probably healthy for them too. Seaweed's healthy for anybody. I think if you had the right.
Yeah, no, that's good.
And then some other ones include. You have certain type of plant extracts that have been shown to reduce it by around 33%.
It will also be good in this bill if they would provide a little bit of subsidy to the farmers for additives like that.
Another measure is doing manure management from confined animal feeding operations by constructing anaerobic digester units.
Yeah, so the other thing too was the manure management.
Okay, so far we've talked about free range cattle. Okay, that's our number one recommendation, right? I mean, that would go a long way. Additives are the next thing. I think that's second, close second, right? Now let's talk about what you also recommend is manure management, right?
Yeah, so we can do manure management, and the usual way of doing that is they build anaerobic digester units, which are like big dome structures, and you mix manure with other feedstocks and water. And you let it ferment with the natural microbes, and that produces methane. And then either you combust that methane and produce power out of it, or use it for heat. So they do that.
However, the best method for manure management comes from smaller companies that can recycle the nutrients into fertilizer while producing clean water for the farm fields again.
But we're kind of looking into some other solutions which we think would be a good idea, and I want to talk about those a bit. Two of them are from companies that we saw. These are kind of novel methods that you could do that people could institute or whatever to kind of help with their manure management. It does a couple things like.
And I mean, talk about manure management with the restrictive feed cattle only, right? So that's because that's the problem. Yeah, okay.
Yeah, not the free range cattle, but
right.
the ones that are the confined feeding animal operations.
Right.
So when you do these kind of manure management, what it can do is that it can remove the nutrients, the nitrogen and phosphorus nutrients, and then create a better fertilizer product. I'll get into those into a bit. And then you also create cleaner water. You take away those nutrients, you create more purified water, which you can use again on the field to irrigate your fields and stuff. So a couple examples, a couple companies I wanted to talk about that kind of do this. One is called Biofilter, and they have this system where they have these drainage basins, and they add mixtures of gravel, wood chips, earthworms, and microbes. And they add them all together, and then they put in the manure effluent, and then the earthworms and the microbes tend to break down all the solids and then take away the nutrients and create clean water. And in the process, you make earthworm castings, which they've been shown as a good fertilizer.
Yeah, it is. Yeah, that's right. Yeah.
And it actually has been shown to sequester the carbon from the air. So that's actually it's
double whammy again.
Yeah, it's like biochar. It's something very similar to it. There's another system from a company called Genefuel out of Utah, and they actually worked with the Pacific National Energy Laboratory in Washington, and they worked on a liquefaction method. Which they originally used with algae. I think they used algae to produce liquid biofuels from liquefaction.
PNNL is a DOE lab.
It's a Department of Energy lab. So, anyways, so they started doing that, and there's two different processes that are involved with it. And so, but they found out you could use it for wet feedstocks like manure. So they kind of advocate you could use manure for this. So, it has two different kind of processes linked together. One's hydrothermal liquefaction, which is that process, and is coupled with catalytic hydrothermal gasification. So the liquefaction process produces biocrude oils, which you could either put directly into like boilers or generators to create electricity or heat, or you could sell it to a refinery that's making liquid vehicle fuels. So you do that. It then produces a fertilizer type product, which is, I think, is similar to struvite, which is a slow release fertilizer, so it wouldn't solubilize in the soil. The phosphorus wouldn't. And then it goes to the catalytic hydrothermal gasification stage, and that produces methane, which you can use as a gas, for heating and electricity, and then it produces clean water.
Yeah, very good. All right, so thank you for joining us in this episode. We'll bid you adieu, and until next time, we're the Climate Change Brothers, Frank and Matt and Frank, whatever. Right?
Yeah, Dr. K.
Dr. K,
Call me Dr.
All right,
K.
very good. All right, signing off. Thanks.